high 90s and triple digits. Today it's 104 degrees. So I'm sitting out here in the Robothut with the camera talking to you because it's the coolest place in the property. There's no air conditioning in the house and there's definitely no air conditioning in the shop. But because there's no windows and only one door that opens, and I insulated this building so well, it's a nice 65 degrees out here, very comfortable. Got the overhead lighting off. The light that's shining on me is what we're going to be talking about today. Because of the high heat and the grass still grows because it still gets watered in the very early morning hours, I got tired of mowing in the heat, so that means I need to start mowing 9, 10 o'clock at night when it would at least cool down to 80. And I can't see the grass at 9 or 10 o'clock at night. And my Atlas electric lawnmower, it's an 80-volt lawnmower, doesn't come with headlights. So I thought, well, what if I take one of those dollar store 100-watt lights and modify it? All the LEDs inside the light are in series. They purposely series them up to be able to handle the rectified 120 volts AC to DC, which gets close to 160 volts. So I figured, what if I ran half of the LEDs, made a break, and ran the other half in parallel with the first half, all off my 80-volt battery in the lawnmower? I decided, well, I don't want to kludge my lawnmower just for a heat wave that hasn't happened in 150 years before. So I'm going to use a separate battery. The lawnmower can hold two. I'll use one to mow, and I'll use the other 80-volt battery to run one of the modified lights and just clip it onto the handlebars of the mower so I can see. Well, that's what's shining on us right now. Is I have one of the dollar store. You get two of them for $1.25, so 60-cent 100-watt lamp, which I've rewired to work off of 80 volts. Works very well. Only draws 100 milliamps. So that means, well, it means it would run 10 hours on 1 amp, and at 80 volts they're 2.5 amp hours, so it's can run more than 24 hours off a single battery on the 80 volt. And I said, well, if I share this with you guys on YouTube, there's a lot of you that don't have the 80 volt yard equipment yet. Most of you, not most of you, but some of you might be running the 40 volt because it's been popular for a while. So I modified one of the bulbs to go down to 40, which means I could, there's 15 LEDs in the Dollar Tree 100-watt lamp. When I run it off 80, I take 7 of them as one group and 7 of them as the other group and remove the one in the middle to break the circuit. When I run it off 40, I do it in groups of 3. 3 LEDs is one set, take out an LED, 3 next 3 LEDs is one set, take out another LED. I group all those groups of 3 together, and it still only draws 100 milliamps because of the current regulating chips that are built into the light bulb, but it runs off 40 volts, and at 40 volts you actually have 5 amps on this particular Atlas battery that I've got, so it would run over 2 days. So I'm going to show you the bulbs and the drawings. In order to do that, I'm going to turn on one segment of the lights in the shop over there by the camera, so you can see these little drawings that I've made. So let me hit the breaker. Okay, and I'm going to take this light, I'll light it over here. Alright, I'm moving you around. May have to move you around quite a bit in order to show the drawings and everything. If we get that far, we'll see how it goes. So for those of you that aren't aware what I'm talking about, at Dollar Tree, they come in a box like this. You get 2 of them, and right there, that's what it says. There's the specifications for it. This one over here that's lit, which you can see, I'm going to turn it off so you can see better. I put a clear lens on the front of it because I wanted to project light out into the yard to see where I'm going. And I've just got it on an old clip lamp house thing that I've got. In this case, for this demonstration, I'm using this device, which I've did several videos on before, where I can plug in one of my batteries and I can plug in there to get 80 volts, or if I plug in a second battery, I can plug in there to get 120. So I mean, I can run a bulb not modified at all if I want. But that was just what I was doing out here to demonstrate this. I can also, I'm going to carefully mark the bulb 80 volts so no one will accidentally screw them into a 120 volt AC socket. And this one I've marked a 40 volt. No, they would work if you screwed them into a 120 volt AC socket. It's just that the current limiting chips in there would probably get pretty dang hot because they'd be doing a lot of work that they're not normally used to doing. I'm going to take the battery off this here. And just for the sake of a demonstration, see on these batteries, you've got, because it's 80 and 40 volts, so you have two positives, you've got two negatives. I'm going to grab one of the positives and one of the negatives, and that's going to give me 40 volts. And we'll plug the 40 volt bulb in. This is more like what I had inside the lawnmower when I ran it. And this one, as you can see, I left the white dome on, so it wouldn't be good for projecting light. However, this would be a very good setup as a backup lighting, like if you have a power outage and you need the light. But this one will also allow us to see what's going on inside, because I can just pop that housing off. On the clear one, I think you can kind of see in there. Basically, let's turn it this way. I wish they'd started numbering where that number 7 is. If they'd made that number 1 and counted around, it would have made life easier. But anyway, they didn't. They start number 1 clear the hell over here, so it goes to 1 through 15. So in this particular case, it's 7. Start counting as 1. 1, 2, 3, 4, 5, 6, 7. So 13. 7 through 13 is going to be one group of my LEDs. Just took some snippers and nipped out bulb number 14, LED number 14, and then 15 all the way around here to whatever number that is there is the next group. And you only have to add 2 wires, because you see, starting at 7, this connector right there runs the full B plus into the anode end of 7, then the cathode end of 7 connects to the anode end of 8. In other words, they're all in series. So if we bust this one LED out over here, we've broken the chain. So in order for this to light, since it's got positive going there, it means it needs a negative. So I ran one wire over to the negative side. These chips all have their pins grouped on this side as all negative. And that would turn that first group on. Well, the second group already has its one end to the negative, so I just need to bring that positive over to it. And it's easy to solder once you've broken the LED out. You can solder right to where it was, and just take your own meter first to make sure you didn't make a little solder bridge there where the LED used to be, and you're good to go. So the 80 volt one is really simple. The 40 volt one means since you've got so many more groups, you've got to do it so many more times. So in this case, I color coded them to kind of maybe make life a little easier. Let's turn this in the direction that the other bulb was sitting. So this is the positive. There's a filter cap behind that. There's a diode bridge, which means it doesn't matter which way we connect our DC power up. So the red wires are all the positives, and I have the group of 3. You got 3 LEDs, you got 3 LEDs, you got 3 LEDs. So in between all those, you bust those other LEDs out. So if this group anode already has positive, that means the end of this LED needs negative, which we can grab right there.
and I brought it over to that end that needed negative, and brought the negative over to one of the current limiting chips. Like I say, all 4 of those pins on the current limiting chip are negative. All 4 of these are tied right into the same negative. So I can grab negative off any of those. I'm going to try to make it a little bit clearer for those of you that don't fool with this kind of stuff too often. With a diagram, which I got to get far enough back so the whole thing's in the picture. So you can see the LEDs were all in series. This is the 80 volt version. And if we bust one LED out, in this case it's the one that's marked number 14 inside the lamp, bust that out, then I'd simply need to bring a ground up to there, and bring a positive down to there, and then these 2 strings of LEDs are now in parallel with each other, all running off of the current limiting resistors. The whole thing still only draws 100 milliamps with an 80 volt input. And that's how you do that. Like I say, it just takes a few more wires to do the 40 volt one, because you're breaking it into groups of 3. So you have your full string of LEDs, and every 4th you go 1, 2, 3, 4, remove that one. So in this case it's number 10. 1, 2, 3, remove that one. In this case it's number 14. 1, 2, 3, remove that one. In case it's number 3. And it means you're going to have to run 3 ground wires, and you're going to have to run 3 positive wires. And then you can light these groups all in parallel with each other off the same current limiting chips at 40 volts in. It's still only going to draw 100 milliamps because that's what these chips are regulating it at. And that's all there is to it. Just having a little fun. Like I say, once you break an LED out and solder wires on, you should go across that with your ohm meter first to make sure you didn't make a little solder bridge there, because the last thing you'd want to do is short ground directly to V+. It would either take out these current limiting chips, wow, you just lost 60 cents, or it might blow the little 10 ohm resistor that's actually in series with the V+ that comes down to this end of the bulb. There is a 10 ohm current limiting resistor that also acts as a fuse. Anyway, you don't want to blow the resistor or the current limiting chips. Just take your old ohm meter and make sure that you don't get a dead short between any of these connections. And as long as you don't get a dead short there, it's probably going to work. Probably going to work good. Just like this. And if you need to project the light, remove the dome, and then you can really send the light wherever you want it. Works really well. Too bright for the camera, right? Well, that's because it's supposed to be about 1500 lumens. What do you say, Robbie? There we go. Well, it's still hot. I think I'm going to go back and sit in my easy chair. Just going to kick back and relax for a little while.